हरिः कर्ता।
Now let's get back to the statistics. So now we will see how to calculate summary statistics. Okay. So for that we are going to use same the previous users data, and we'll be doing with the pandas. So let's get into our notebook first. I'll save this, and let me check this, close this and open a new file. Rename it to summary statistics. Okay. Import pandas as pd, then let's read the file. So users, I'll say users data frame, or this time I'm gonna say passengers data frame. So pd dot read csv, and read csv. Inside that, let me get, yeah, users.excel user data.csv. This is what I want. And so passengers df, and here is our data. So clear. So our data is ready, our data frame is ready. So now let's get back to our slide, and let's check what all we'll do. We'll begin with the aggregating statistics. So what is aggregating statistics? The first question, so here is, you have a different series in your data frame, and we just want to aggregate one of the series, and we just want to get the aggregate value of that series, or that column is called as aggregating the series. So here I'm adding all these yellow colored series values, and I'll get the aggregate value as this uh, pink one. So the first question for me here is, let me do that. So what is the average age of the passengers? Mark down 3. So let me take the df, it's a passenger df data frame, and let me directly take the age series, and I'll just get the mean of it, and here is that. That's it. This is what the aggregation I'm talking about. Here you can see that this is age series, and it's been aggregated into the single value, that is 29.699. So different statistics are available and can be applied to columns with numerical data. So operations in general exclude missing data and operate across rows by default. It operates across rows. It operates across rows. Okay. So now let's look into the second one. So here we have the data frame as usual, and we just want to aggregate based on two series. So two series, the aggregation depends upon two series. So what is that aggregation? What is the median age and ticket fare price of that Titanic passengers or the passengers? Okay. So one is median age and then ticket fare and then of those passengers. So lot of things are involved. Let's do that. So what is the median age and ticket fare price of the passengers? Okay, so let me take passengers DF, and as we have different total two series or two columns, age and the ticket for fare, so I have to take the list of those column headers. So what I'm gonna say is, first one is, sorry, age, and second item here is fare. Done. Let me get it. You got the two columns, specifically those two labels. Now I just want the median of these two, so age as well as fare. So I just want a median, so let me give median. Yeah, and okay, yeah, and here is the a median age is 28 and median fare price of the passengers is 14. So 28 and then 14, it's a float 64. Both the parameters are float 64. So here, so this is where we have applied. So we got two aggregations. Two aggregations we got. One is for the age, other one is for the fare. Okay. So the statistics or the statistic applied to multiple columns of a data frame. Example, the selection of two columns returns a data frame. So it's calculated for each numeric column. So the aggregating statistic can be calculated for multiple columns at the same time with a simple method called describe function. So we will look into that also. So, but it's specifically for these two series only. Okay, this is only for these two series. So apply describe only for age and fare. Okay, so now let me do that. Let me copy this directly and paste it here. So let me change it to describe. Okay, and execute it, and here is the complete statistics. So count total 714, whereas fare 891. So remaining in age are null values. And what's the mean of age is 29.69. So this is the mean age of the total passengers in that ship. And the mean fare is 32.204. Standard deviation is 14.52. Okay, it's huge. The standard deviation is 14.52 years. That's huge. Oh, even the fare is 49.69. That's the standard deviation. That's also huge. Why? So minimum is 0.42. Fare is 0. That's the minimum. And here is the more information. And then you got the maximum values. And in between you have few more details. Okay. So now let's look into one more method. So this time what we are gonna do here is so instead of the predefined statistics, specific combinations of aggregating statistics for given columns can be defined by using the method called agg. Agg. Let's do that. So customizing aggregations. Okay. Mm, let me check. Use passengers df a data frame and use that method agg. So inside that agg, so what I'm going to type here. So first I want to do it. Okay. So first I want to do it for age. So for age, what all aggregations I want, I just need to give it a dictionary. That's it. Okay. So let me bring it down here. Yep, done. So now indentation problem won't come. So now I need to, age is my key, and what all aggregations I want to have, that's my value. I'm gonna give a list value. So I want a min, and I want max, and I want median, and I want skew. And one more key value pair I'm gonna give. So we'll keep the same min max median skew, but this time I'm gonna mention a different series label, that is fair. And that's all. Let me execute it. There is something wrong. What's that? Passengers.df. Okay. Age min. String indices must be integers, not tuple. Okay. Just a minute. So this is aggregation. Okay. Okay, got it. So I forgot to put this one. Sorry. Absolutely sorry. Yep, it's done. So we missed the colon. It's a key value pair. We missed the colon. That happens while typing. Okay. So for H, minimum, maximum, median skew, and for the fair, minimum, maximum, median skew. You can clearly see that min, max, median, skew. So skew is higher for the fair. It's a 4.78, whereas skew is just 0.38 here. So median is pretty good, and maximum values are this much. Fair is 512. This is the maximum value. Okay. So we can apply different statistics which are available and can be applied to the columns with numerical data.